What is material science and engineering? Materials have been central to the growth, prosperity, security, and quality of life humans since the beginning of history. Only in the last 25 years, and especially in the last decade, has the intellectual foundation of the field that we call material science and engineering begun to take shape to achieve recognition. Without new materials and their efficient production, our world of modern devices and machines could not exist. Material scientists and engineers will continue to be at the forefront of these and other areas of science and engineering in the service of society as they achieve new levels of understanding and control of the basic building blocks of materials.
3,000 different of type of materials, but most of scientists create new materials in new ways. The number is almost infinite. That's the way that the materials fit into a big general category. Metals. These are the first materials to be engineered, that the people changed them to fit that they needed to do. Ceramics. The ceramics can be used to create the tooth replacement and China ribbons.
Material structure. All matter is considered to be composed of unit substances known as chemical elements. These are the smallest units that are distinguishable of their basis of their chemical activity and physical properties. The elements are composed of atoms which have distinct structure characteristic of each element. An atom consists of a unit positively charged nucleus surrounded by a sufficient number of electrons to keep the atom as a whole neutral. The electrons or protons have equal but opposite electrical charge, so the neutral atoms must contain an equal number of electrons and protons. There are two types of bonds: primary bonds. Primary bonds are the strongest bonds which hold atoms together. The three types of primary bonds are metallic bonds. In a metal, the other electrons are shared among all the atoms in the solid. Each atom gives up its other electrons because slightly positively charged. The negatively charged electrons hold the metal atoms together. Since the electrons are free to move, they lead to good thermal and electrical conductivity. Covalent bonds. Some atoms like to share electrons to complete their outer shells. Each pair of shared atoms is called a covalent bond. Ionic bonds. Atoms like to have a few outer shell of electrons, sometimes by transferring electrons from the atom to another electron shells or field. The donor atom will have take a positive charge and the acceptor will have a negative charge. The charged atoms or ions will be attracted to each other and form bonds. Secondary bonds. Secondary bonds are much weaker than primary bonds. They often provide a weak link for the formation or fracture. Examples for secondary bonds are hydrogen bonds. Hydrogen bonds are common in covalent bondless molecules which contain hydrogens, such as water. Van der Waals bonds. Van der Waals bonds are very weak compared to other types of bonds. These bonds are especially important in noble gases which are cooled to very low temperatures.
Physical properties. Really on the structures and material processing. Describe features such as color, electrical or thermal conductivity, magnetic and optical behavior, usually not altered by force acting on the material. They can be divided into electrical, magnetic and optical. Physical properties of matter are categorized as either intensive or extensive. Intensive properties that do not depend on the amount of the matter present: color, odor, luster, malleability, conductivity, hardness, melting and pressing point, boiling point, and density. Extensive properties that do depend on the amount of matter present, as weight, length, and volume. Chemical properties This describes the system and their ability to change into new substance and with different properties, permeability and reactivity.